Hello. Hello. Hello, am I audible? Hello, am I audible to anyone? Hello, am I audible?
Hello. Yes. Sorry, I was just waiting for others. That's what we have done before. You want to ask something, Nilesh?
Am I audible, sir?
Yes.
Fine, fine, sir. Okay.
Okay.
Sir, have you prepared the assignment 1 to 8?
Yes.
So in that, some of the answer is just written in that using the MATLAB. But in a final examination, we don't have a MATLAB with us, right, sir? So how to solve those kind of questions?
Without MATLAB?
Sorry.
Means which type of questions? That's
In
all algorithm based, right?
yes, in assignment, some of the answer is provided in solution of that answer is in detail. Some of the answer is just written that using the MATLAB we are getting this answer. But
Have you got the detailed solutions?
sorry, sir.
Have you got the detailed solutions of your
Yes,
assignment?
yes. From assignment 1 to 8, we got a detailed solution. But in
Okay.
that also, some of the question is just answer of some of the question is just written that using the MATLAB solution.
Okay.
So how
That
to
should
solve
not be
those
the
questions
case.
without the MATLAB
That should not be the case. Means in
in
the
the
assignments.
final
Yeah, in
exam,
the
right?
final exam, your all questions will be solvable without using MATLAB.
Fine. But
Yeah.
sir, if the similar question asked, then what is the procedure we have to follow? Because using the MATLAB, if some of the question you can solve, which is also not there in the assignment, there is no issue, but similar kind of questions. And in assignment 2, question number 4,
Hmm.
the answer given by you is different than the answer is correct given by the NPTEL.
Answer given by me.
Yes, in assignment, in detailed solution,
Okay.
assignment 2, question number 4.
Okay, question. I will just note down so that I can.
Fine, fine, sir.
Can you write an email based on that so that I can
I'll
forward it to
already
the groups?
already already write an email to the forum, sir, but awaiting for the reply.
But you can forward to me so that I can
Fine, fine,
immediately.
fine. I will do that. I will do that, sir.
Yeah.
Should we start now, sir?
Yes. No one comes nowadays. Do you know someone who has joined this course? Why the people don't come in this?
No, sir.
Okay.
So today you are going to solve a question based on assignment 10. Am I right, sir?
Yes.
I already sent you the assignment 10 questions. I hope you got in my email.
Yeah, I have seen.
Fine, sir. Thank you.
Okay, I just share the screen. Can you see the screen?
Yes, sir, it is visible.
Okay, so we will discuss today numerical differentiation and integration. I hope you have seen the lectures based on that. So the idea is how you can differentiate a derivative. Okay, so basic approach is, so what's the definition of your derivative with respect to x? So f is a function and the derivative of f with respect to x at some point x equal a is limit of f at a plus delta x minus f of a divided by delta x as delta x approaches to 0. So it's kind of approximation to a function, relative approximation for a function that's near to the closer to the point A. So if you omit this delta x tends to 0 term, then you get some kind of approximation, which is given by this f a plus del x minus f of a divided by del x. Okay, so the definition and the approximation. So this is a bit clear. Okay. So that's called as forward difference approximation. So if I write here somewhere, forward, forward difference in which we take only the values fx plus del x and f of x. So f dash x is approximated as fx plus del x minus f of x divided by delta x. And on the other hand, you have backward difference approximation, which says that you take the values of f at x and fx minus delta x, and the similar approximation is fx minus delta x divided by delta x. All right. So that's the approximation of your first derivative, and we need to find out like what's the error of approximation. So another topic is the error. So how do you gonna do that? Okay. Error of approximation. So what's the error of approximation in this? Because if you are approximating your function, your f prime is a function, and you are approximating in such a way, then as we have already discussed in the previous tutorials, we need to find what is the error between the exact and the approximated value, because there should be some error, right? It's not the same. So how do you find that? So we use Taylor series to do that. Taylor series expansion. So what does it say? So fx plus del x same as fx plus delta x f prime x plus delta x squared by 2 f double prime psi. So it continues until xi is your belong to 0x. That's it.
What is
Okay.
xi, sir, in that case?
Xi is any number between 0 and x. That's by usual standard definition of Taylor series. Usually comes from, I think, mean value theorem somewhere. It's not, but it's not fixed like this kind of term. If you want to truncate it there, but if you want to move further, then you just pick it up xi at as higher order as you take. Suppose I take here as, if I remove this here, then I can take del x cubed by 6. Yeah, xi is always between 0 and x in this. Is this clear?
Yes, sir.
Okay. All right, so I want to terminate till here because I need only first derivative, not the second derivative. So just here, then, okay, then you can find out the value of f prime here, which is fx plus delta x minus fx divided by delta x minus delta x by 2 f double prime psi. So what is this? So you are
Delta
getting
x
this.
square by 2. Am I right, sir?
What?
Delta x square by 2.
We divide by delta x. You shift it here, divide by delta x.
Fine, fine.
Yeah. So this thing is kind of your error of approximation, okay? Because that makes you apart from that. So we
So
ignore
signature
this.
is having any role? Plus or minus is having any role?
Plus or minus, because we always take absolute error, right? So
Yes.
it doesn't matter.
So in
So
some
you
of
have,
the equation, it is written plus delta x by 2 f derivative of psi.
you
So is
mean
it true?
plus they take or delta h by 2? Yeah, it's true.
Okay.
If you subtract it over here, then you will get negative sign, of course, that's true. And if you look here as well, then it's, yeah, that's true. So just take here h is delta x that I've taken, and this is the error. Okay, is that right? Is that all right with you? Okay. So idea should be very clear. And so what is the order of the error? It's order of delta x. Or if you are taking delta x equal h, then it should be order of h. Okay, so that's called as the truncation error. You know the difference between truncation error and global error?
Truncation versus which error, sir?
Truncation, yes.
Truncation error and other one is?
Global error. So here global and truncation are same because you don't have pieces of intervals. But if we go over integration, then they are different. Wait, I will show that later, but keep in mind. So is this clear to everyone?
Yes, sir.
Okay. So it's just a small exercise. Just try to find. Okay, just keep. Okay, so I just give you find. So that this formula is called as where is that? So this formula is called as the difference formula. Difference formula. If you approximate it. So find truncation error. It's not a nice way to write in this. Okay. Find truncation error for the difference formula. Okay. So I give you, what's this? Okay. Okay, maybe you can try that. F prime x equal fx plus. You can try this. Okay, and just try this one and let me know what you are getting. You wait. See this one level. So I would suggest you to do an exercise in the book that do this. Okay. Yes. So just try to prove that, okay, the first derivatives, all these four formulas over here, if you can see that, just prove that and find the order of h square, h4, h square, h. Just try to solve all the four parts and let me know. Then you do for second derivative, then third one, if whatever feels convenient. Can you try that? Okay. Just take some time for the formulas for first derivative. Make difference equations out of it. For example, the first one, f prime x naught equal f1 minus f naught divided by h. So f1 is your fx naught plus h. So I just write here as a demo. F prime x naught is f1 minus f naught divided by h plus order of, okay, order we don't know, suppose, then you have to prove it. So f1 is basically your fx naught plus h and f naught is fx naught. Find the truncation error. Okay. Just try once. Any doubts, ask me.
Sir, solve one question, then we'll solve another one.
I've actually solved one, so it's similar. The first part I've solved. This one. First one I have solved for the first derivative. Second one you can solve. And second one is basically your central difference, which say you take only one, and f minus 1 is x naught minus h. And then you solve these three. Just try, at least.
Hello.
Yes. Have you tried? Just try.
Central difference is complete, sir.
Okay, how do you do that? You are getting the same error?
It is actually order
Okay,
of S square.
okay. You have tried another one as well?
Which one, sir?
The last, that one, next one, third one.
No, only second one.
Try at least third till third.
So for that we have to find minus F2, F1 and F0, right?
Yes.
Still, sir, have some confusion. Will you please solve one more?
The central difference I should solve, or
No, third and fourth maybe.
third and fourth. Okay. Okay. F prime x naught is, let me write
Let's say
it.
in assignment, sir, question number 3 is there, in which they are asking for the uh, what what form does the truncation error take from the differential formula. So similar kind of question, if you can solve.
So that will be for higher order, right?
F4x, yes.
F4x, yes. Okay. Similar kind of that. So I can solve, that's not similar, of course. Okay, I can solve the first part of f4x, right? But that will be too much. So should I start with the basic one? Then I will go with that.
Fine, sir.
Okay. So for the central difference, it was easy, I think, for you. But let me do this first so that I can catch the back. So how did you do the central difference first? What's your strategy behind it? So you have fx plus h minus fx minus h divided by 2 times h equals to f prime x. Okay, that's your difference scheme, difference equation. Okay. Then you transform it to, okay, so how do you do that? Okay, how to find the order? So you have fx plus h, you can write it as fx plus h f prime x plus h square by 2 f double prime psi fx minus h as fx minus h f prime x.
Sir, where we have to stop? S square by 2f double
You have to
derivative
stop
side.
till this f double prime because you
How
don't
we
have,
know that? How we know that we have to go further or not?
because you only are approximating this first derivative, not the second.
If you're doing second, then go.
If you
Okay,
are
fine,
approximating
fine.
second, then yes, go third.
Okay.
So just subtract it and you will cancel these term, right? So fx plus h minus fx minus h divided by 2 times h, that will be your 2 times h. So you will get f prime x. And but the thing is, here is the tricky part, right? So these terms are already gonna cancel, right? So you need to consider more terms. X cubed by 6 f triple dash psi, and here also h cubed by 6 f triple dash psi. So if you just subtract, okay, here is, wait, here that comes with negative part, that also comes with negative part because you have, okay, that comes with positive and that comes with negative. So if you subtract, then it will add it, it will add, so it will just h cubed by 3 f triple dash psi. Okay. And you divide by h also, so it will be order of h square. Yes. Is this clear? Okay.
Why you divided by h, sir?
Order of h square.
Okay. Okay.
Yeah, because you want to get the same expression, right?
Yeah.
That's,
Okay, fine.
I think everyone is clear with this.
So there is a no significant of 3 below s square by 3. So we have to write order of s square, right, sir?
Yeah, if the question is asking you exact truncation error, just write all.
Okay. And sir, go ahead. The question you given to us, just go ahead. Go to that question.
Which one? Okay,
Go
fine.
upside. Go upside. Go upside. No, no, not that one. You written
Okay,
in the book in the notepad.
this one.
For this one.
I think I've written it wrong, right?
So x plus
Yeah.
2h. It is there x plus 2h and
So if
2h
you
and
do
4h.
fx plus 2h, then what you do?
So we have
Fx,
to
same
solve with
procedure
the
with plus 4h square.
fine, fine, sir. Okay, got it, sir.
Like this. Yeah. Okay, so I can solve now for the fourth derivative you are saying? Oh, this one first you are saying. I think there is some
Question given
issue
in
with
assignment.
the third question you are saying.
Yes, similar to that question, sir.
So similar to that is this one. So I will do this.
And in
So
second also f double dash x. So both are I think similar one.
this one you want to Like, okay, second derivative, you are saying I just solve
Second
one.
and third question, second and third, both is it. So similar question of assignment question second and third.
Question second and third. Okay. Okay. So F double prime, I can. So have you tried this F double prime one?
No, sir.
You want to try this first? The basic.
Sir, actually time is limited. Now we have to finish.
Yeah, we
We
have
have
to
to
finish
touch.
integrals as well.
So please go ahead, sir.
Okay. Okay. So F double prime x naught. If I what questions should I solve in this? The first part or first part would be good. Okay. So I just do similar one and you can try this. Okay.
Just guide us, sir, how to solve the question number
Okay.
2 and 3. We'll do it at our end if required, but just guide us how what
So
procedure we
yeah.
have to follow.
So F double prime x naught is F2 minus 2F1 plus F naught divided by that h square. Okay. All right. So it is basically I just take x instead of x naught, fx plus 2h minus 2fx plus h plus f at x naught divided by h square. This is your f double prime x. Okay, so see what terms are coming. Fx plus 2h, fx plus h. Just expand these until you cancel terms. So fx plus 2h is until you get f double prime x. So it is fx plus 2h f prime x plus 2h square f double prime x plus, okay, so it is what you have done in this h square by 2. Okay, that would be cancelled and 8h cubed by 6 triple dash psi minus. Okay, so another term is fx plus h, which is fx plus h f prime x plus h square by 2 f double prime x plus h cubed by 6 f triple dash psi. Okay, and fx naught is there. Okay. So that is fx basically. So just subtract these two terms. So if you subtract fx plus 2h and fx plus h, and is there minus. So what terms you gonna cancel? Fx to fx, 2h minus h is your h f prime x. Okay, so you get okay h f prime x and 2h square minus h square by 2. Okay, what is this? Is basically you have to multiply by 2 over here and then you need to subtract it. Okay,
Fine, sir. Got it.
yeah. So you are you getting the same order?
Sorry, sir.
If you subtract it, okay, 2 times that will be h square and h cubed by 3. Okay, so this term will not be subtracted actually. So that you will get as minus, okay, anything minus f prime x minus fx. So fx minus 2fx is minus fx. 2hfx and 2hf prime x, they all got cancelled. 2h square and h square, they just h square. And then you somehow you have this term order of h cube. Okay, So you divide by h square on both sides, and you have fx as well in addition. So this fx will also be cancelled. So you can divide by order of h square. So you get order of h. I hope you understood. It's not so writing is. Okay, so similar to that we have done, and fourth order you can also do that. Should I try fourth order as well?
Is I think lengthy question, right, sir?
Yeah, but you can do in the same way, right?
Fine, we'll do
So
it.
for this,
So
I
now,
would suggest, yeah.
now, sir, 1, 2, 3, 4, 5 is clear. 4, 5 is also easy. Just
Okay.
can you throw some light on question number 6, 7, 8, and 9?
Yeah, that's what I'm coming. Okay. So 4, 5 in your assignments are based on forward and backward difference formulas. That's all.
Yes.
Okay. So trapezoidal rule I have to come up with, and Simpson's 1/3 rule. Okay.
Yes.
And the errors of this. Okay. So is this clear to everyone? Okay. So you can do that in the same way, but yeah, maybe lang based on that. So
So
what is
the similar book
trapezoidal?
is,
Yes.
it is already said, the book you, from you are showing this book, right? It is a it is the same book you share in the
Yeah, yeah,
uh,
yeah. It's the same.
because the some of the page number I'm the finding bit difficult to compare with your book.
Some of the page. So why is that?
We'll
I
again
have shared the same book in the tribe link.
fine, fine, okay.
Yeah, let's try this. Okay. So how do you approximate the integration now is, yeah, that's the usual definition of integral fx. And if capital F is the antiderivative of small f, then you can just write in just difference of two functions, jiggle it around. So what is trapezoidal rule for integration? So you kind of having 2 points. So this is the graph of the function if you see my cursor. And there are 2 points, xi and xi plus 1. You calculate the value of f at xi and f at xi plus 1, fi plus 1. Then you can easily approximate your integration by this, which is kind of taking the mid value of the function fi plus 1 divided by 2 and the difference of the xi plus 1 at xi. This is kind of x-axis and y-axis. Okay, so that is the usual trapezoidal rule. And okay, so, and this is somehow another definition. So just remember that error of integration in trapezoidal rule is this, order of h cube. So that is called as the truncation error. But let's see how this truncation error becomes global error when. So if you multiply by nh, okay, I just show you then. So what is the trapezoidal rule? And so what is the difference between trapezoidal rule and composite trapezoidal rule? So this is the definition of trapezoidal rule, h by 2 fi plus 1 if you have 2 points. Okay, so I just write it here. Okay. Trapezoidal. What's that? So you have a graph of function f. You have 2 points xi plus 1, then fi plus 1. Then you do that. You want to find this area of integration. What's this area? Then this is basically xi to xi plus 1 f dx is just your approximated as fi plus 1 divided by 2 into xi plus 1 minus xi. That is your, so if it is given this length is suppose h is xi plus 1 minus xi, then it is just h times fi plus 1 divided by 2. Okay. That's it. So that is your trapezoidal rule, and the order of truncation error is HQ. Okay. So the difference between global error and truncation error is, so now global error. So that will come from composite trapezoidal rule. But in question number, you are saying about which question? 6. So suppose you are given an integral
Yes,
of,
6
okay,
to 9.
okay, find integration of 0 to 2 sine x dx using trapezoidal rule. Can you do that now? Solve it using this formula. So what is xi? X0 is your 0 and x1 is your 2.
H
F0
is
you
2.
can 0 and F1 is your
Sine.
sine 2. So it's easy, right?
Yes. So answer
So
is 2
that's
sine
what
2.
your question is. That's your question about. Sixth question is based on that.
Fine, sir. It is okay. Clear. What about
Sixth
7, sir?
question. I'm not come to Simpson rule yet. So after that, so
Okay.
we will try
8.
to do like eighth similar to trapezoidal rule. Yeah. Okay. We are not talking of composite in the, I think in the assignments. This will come next, right?
Yes, sir.
So I should not introduce a composite rule or global error. I should not introduce. I will introduce next time. But okay, so what is the error in this? Suppose you want to
Correct
find
bound of
out
the error.
the, yeah. Suppose you want to find the correct bound of error using the trapezoidal rule. So what are the ways to do that? Should I solve it? So
Yes,
from
sir.
here is 0 to 2 sine x dx is just approximated as sine 2 minus sine 2 plus sine 0, which is 0 for your convenience, and this is multiplied by 2. So 2 is the difference between 0 and 2. Okay. And yeah, similarly, you can solve your assignment question 6. So how do you find the error bound? So you already know one case find error. That's you already know, like from trapezoidal rule, whatever you're getting, which is kind of sine 2, and what is the integration of sine x? That is minus cos x. Okay. Okay. And then you have 0 to 2. What you are getting in this? That is cos 2 minus cos 2 plus 1. So is sine 2, just calculate the exact means absolute error based on exact integration minus integration approx. That will give you the absolute error, right? If you calculate the difference between exact and approximate solution, approximate integration, and another is, but that is your error, absolute error. So that will give you error bound as well, right? So error bound is you are getting exactly error, so there is no point of error bounds in, yeah. So what other ways to do that? Let me see.
Not getting the point, sir.
What are you not getting in this? This is the easy way you do, right? Approximate
That
solution
is the
minus,
exact is minus cos 2 plus 1 and
yeah,
minus sine 2 is your my error bound. Is it so?
yes.
Okay.
Sine 2 is basically your approximate and exact solution is minus cos 2 plus 1. So you just
So
subtract them.
So when asking for the error bound, we have to find the first we have to find the integration with the help of the trapezoid rule,
Not
and then we have
always. It's yeah.
and then when we have to find with what is the exact integration by using the integration formulas.
Yeah, that's the one way that I've discussed, but there is another way. So
Okay.
if the question is saying bound of error, not exactly error,
Okay.
then you just write your what is the formula for truncation error? That is this one. Error is minus 1 by 12 h cube f triple dash psi. Okay. So that is minus 1 by 12 h cube triple dash psi. Okay. So what is the f here? F is sine x, right?
Yes.
F psi is sine psi, and f triple dash psi, sine psi equals psi minus sine psi. And then you just substitute over here, that will give you minus plus 1 by 12 h cube sine psi. So you try to find what is the error here. So it is always less than equal to h cube by 12 because sine psi is always less than 1. And h you already know in the question, like if it is 2, then 2 cube by 12 is your error. Is it clear? So these are two ways, but you always, if the bound is asking, then just go by this method. Is this clear to you?
So just a second.
Yeah.
So question asked is e raised to 3x sine 2x. So we have to do a differentiation for a two time, and then we have to find, right?
Yeah, yeah,
That two.
yeah.
Okay.
Okay. So I can just discuss the sin x. Okay, the Simpson's method. That's next one. So that's already clear. And another method is called as Simpson's 1 by 3 rule. Okay, where is that? Okay, Simpson's 1 by 3 and 3 by 2 rules that are already there. So what it takes more values of the function. So it takes three values. The difference between the trapezoidal and the Simpson is just Simpson rule is taking only three values, while the trapezoidal was taking only two values. So it's just have more values of the function. Some point you need more values and more precise. So you just take f naught, f1, and f2 and calculate using Simpson's rule. Error by integrating the error of the polynomial. So you already getting some kind of error estimate in this, which is kind of order 5. Okay, that is the truncation error of order 5. And in the previous case, you were having 3. Okay, it is that. Yeah. So there are two types of cases. Okay, so this is 1 by 3 rule and this is 3 by 8 rule. I discussed this. Wait. Okay. Okay. So what is 1 by 3 rule? 141 and 1331. Okay. Okay. Okay, so what is Simpson's 1 by 3 rule? That is basically your integration of x naught to x2 fx dx. So you have 3 points, x naught, x1, and x2, and you have values of function. Then you try to do this one, 1 by 3 f naught plus 4 f1 plus f2, and Simpson's 1 3 by 8 rule is x naught to x3 fx dx. So if I write here more values, you have x3 h by 3, h by 8. So 3 by 8 coming from this term, 3h by 8 and f
So right
naught
now 3
plus.
by 8 Simpson rule is not part of it 10 maybe.
Okay, but you should remember it.
Fine.
Okay, so these are two rules and they have kind of different errors of approximation as well. So if you want to do that question based on that, okay, so similar to
So
that,
what is
I
the
will.
error portion in the Simpson rule? Because there is a confusion that
What's the
minus
error
n.
of?
Yeah.
Yeah. So error is this minus 1 by 90 h5 and minus 3 by 80 h5. Okay,
Just a second, sir. Just a second.
I just
So
wrote down. So here is error.
in the sir, class it is given a minus n upon 90 h5.
Okay, I just coming. Minus n upon 90 is not for Simpson's rule. That's for composite. I'm not going to that. I will go next time because in your assignment there are no questions. Yeah.
So for Simpson 1 by 3 rule, it is only minus h by 5. Okay.
Yes.
Okay.
So you can solve it. 0 to 2 sine x dx. So how many points you need? 0, 1, 2.
So only the 2 point is given. So how to get for the 3 point? There is a y0, y1, and y2
They
is
will
there, right,
give the
sir?
definition of h
Sorry, sir. Okay.
in the question itself.
Okay.
In question itself, they will provide you what is h.
It is not provided in the question number 7, right, sir?
It's not provided.
Nah. So what is the
If
approximation
it's
value of
not
the h?
provided, then you just assume h is 1
Okay, that is a okay.
by default. In yeah,
Okay,
by default, just try to do evenly, even cut.
fine. Okay, there is only a doubt.
Yeah. Okay. So what is the value then? You just substitute it here. So it's just approximated as 1 by 3. F naught is sine 0 plus 4 sine 1 plus sine 2. That's your value. Okay. And the error is just the fourth derivative of sine, and you can find the bounds on it. Similar to that, similar to a, yeah. Now, if you have any doubts, just ask.
Sir, I have some doubt in week 9 assignments, but you are providing the detailed solution, right, sir? So we'll ask in the next
Yeah.
class if we are not able to understand from the detailed solution of the week 9 assignment.
Okay.
And sir, please give a detailed solution.
Yeah, I have asked, I have just emailed to the professor and he will.
Fine. I hope it is a detailed one, right, sir?
Yeah.
Fine. Okay, sir.
Yeah. Anybody has any doubts?
No doubts, right, sir.
Okay.
Anything else for this class, sir?
No, I've covered most of the things that
Fine, sir.
I just want to ask to when are you guys available for the last 2 hours tutorial? Means after week 12.
Sorry, sir.
I have to take means extra tutorial for 2 hours after second 12th week tutorial before your exam.
Yeah, sir. It is require more lectures, maybe not one, because so many doubts are there, sir. Still, if it is possible, kindly stop the recording, sir. Then we'll discuss.
I need to show like for one like 2 hours recording, but yeah, that's fine. I have to stop at 1:30.
Sir, if a time is there, then we can solve the assignment 9 questions.
Which question you want to ask?
Assignment 9, question number 6 and 7.
Assignment 9, 6, and 7. What is the problem in that? Yes. Assignment 9 related queries. Question number 6. Have you not submitted your assignment 9 yet?
Already submitted and not getting the marks, sir. It's a
Okay.
wrong answer from my side. That's why asking.
Question number 9. Okay. What is the value of A naught? Least square approximation of first degree. Okay. I think that's you have to do it by usual way, right? That's a bit. I open this file. In this, we have discussed that. That's the least square method.
So if you prepare the solution of week 9 assignment, then we'll discuss that solution.
Okay. So you just have to subtract and you have to take del I by del E naught and del I by del E1 equals to 0. Okay, and then find the approximation in terms of A, then you find A. Okay, once you get the week 9 assignment solutions, detailed solutions, just you can share here or on the email, maybe here we can discuss later.
So can we have your WhatsApp number so we can ask a query on the WhatsApp? It is possible.
WhatsApp number.
Yes. So after the 130 hour of recording hour, you can share if it is possible. If you don't want to make it public, then after recording, if it is possible.
I just share my email only. So okay, we can discuss after recording. Um,
Okay, sir.
Please wait for 10 to 15 minutes.
Fine, sir.
Yes. Now tell me what you want to ask.